Here's a deep dive into every section of the context with cancel functionality, breaking down the logic in even greater detail. 1. Creating a cancelable context. What's happening? A new context, CTX, and a cancel function are created using context.WithCancel with context background as the root. This CTX acts as a signal carrier, and the cancel function allows manual signaling to stop all operations tied to the context. Why use context.WithCancel? It enables fine-grained control over goroutines, ensuring they can be stopped gracefully when the parent function determines they're no longer needed. Key takeaway: context.background is a root context that doesn't carry any cancellation or timeout signals. It's a blank slate. The derived CTX is where the cancellation behavior is introduced. 2. Launching a worker goroutine. What's happening? A worker function is executed as a goroutine. The worker takes the context CTX as a parameter, ensuring it can monitor for cancellation signals. Inside the worker, a loop is used to simulate continuous background work, e.g., processing tasks, fetching data, or printing logs. The loop ensures that the worker can check for signals repeatedly. Why pass context to goroutines? It avoids global state and ensures that each worker only monitors its assigned context. This approach keeps the goroutines isolated and easier to control. Key takeaway: the worker relies on the parent context for its lifecycle, ensuring it doesn't operate independently of the parent. Monitoring context cancellation. What's happening? Inside the worker's loop, a select block is used. 1. Default case. The worker continues its tasks, e.g., printing, working. This ensures the worker remains active until a cancellation signal is received. 2. Cancellation case, CTX.done. The worker monitors the CTX.done channel, which is triggered when the cancel function is called. Upon receiving the signal, the worker prints a message, e.g., stopping worker, and exits the loop. Why use a select block? It allows the worker to perform tasks continuously, default case, while simultaneously listening for cancellation, CTX.done case. Key takeaway: the CTX.done channel acts as a one-way signal for the worker to know when it should stop. 4. Simulating work in the main function. What's happening? The main function simulates its own work, e.g., sleeping for 2 seconds. During this period, the worker goroutine continues performing its tasks in parallel. The main function's sleep represents other operations that may delay the need to cancel the worker. Why simulate work? It mirrors real-world scenarios where the main program manages multiple operations simultaneously. Key takeaway: the worker operates independently while the main function handles its own tasks, demonstrating Go's concurrency model. Triggering context cancellation. What's happening? After completing its simulated work, the main function calls the cancel function. This triggers the CTX.done channel, signaling all goroutines using this context to stop. Why cancel explicitly? Explicit cancellation ensures that workers don't keep running unnecessarily, saving resources. Without cancellation, goroutines could become orphaned, leading to memory leaks or unresponsive behavior. Key takeaway: the cancel function acts as the parent's mechanism to stop all child goroutines tied to the context. 6. Cleaning up after cancellation. What's happening? After calling cancel, the main function waits briefly, e.g., 1 second, to ensure the worker finishes its cleanup before the program exits. The worker, upon receiving the cancellation signal, gracefully terminates its operations. Why wait? It ensures that all cleanup operations, like closing files or freeing resources, are completed before the program exits. Key takeaway: proper cleanup prevents abrupt program exits, ensuring that all resources are freed and no goroutines are left hanging. Logical flow of output. 1. Before cancellation, the worker repeatedly performs its tasks, e.g., working. The main function remains idle or performs other tasks. 2. When cancellation is triggered, the CTX.done signal is received by the worker. The worker exits its loop, prints a cleanup message, and stops gracefully. 3. Final state. The main function confirms that all goroutines have stopped and the program exits cleanly. Key features of context with cancel demonstrated. 1. Parent-child relationship. The context establishes a clear parent-child link between the main function and the worker goroutines. Graceful termination. The worker doesn't terminate abruptly, but listens for a cancellation signal and exits responsibly. Efficient resource management. By calling cancel, unused resources, e.g., CPU cycles or memory, are freed promptly. Real-world applications. 1. HTTP servers. Cancel all goroutines processing a request when the client disconnects. 2. Worker pools. Stop all workers in a batch job when the job is canceled or completed. Event-driven systems. Cancel event listeners or background processes tied to a specific event or request. Would you like a further breakdown of specific sections or more real-world scenarios?